Ball is thrown upward from the ground with initial velocity vi equals 11 meters per second and ultimately reaches a height of h above the ground. Neglect air resistance. Part A, what is the acceleration of the ball when it is in the air? If it's in the air, the acceleration is always negative 9.8 meters per second squared if it's unpowered and there's no air resistance. Part B, what is the velocity of the ball Vf when it reaches the top of its trajectory? By definition, the top is when it won't go any further up, so Vf equals 0. Part C, write an expression for the maximum height h the ball reaches in terms of Vf, Vi, and A. We have a kinematic equation for that. Vf squared equals Vi squared plus 2a delta x, where h is delta x. So we can rewrite that h is Vf squared minus Vi squared over 2a. Numerical value of h, when we put in our numbers for the initial velocity, final velocity, we get 6.17 meters. Write an expression for the time delta t it takes the ball to travel from ground to max height in terms of Vf, Vi, and A. We can use this expression, then calculate the numerical value of delta t. We plug in final velocity is 0 at the top. It's 11 on the ground, V initial, so it takes 1.12 seconds. What's the total displacement, delta yt, of the ball going through its entire motion from the ground to the top and then back to the ground? If it returns to its starting point, total displacement is always 0. Write an expression for the total time of flight for the ball from when it's launched to when it's back on the ground in terms of delta t total, Vi, and A. The total time is just twice the time to max height since this is a symmetric problem, and we can write that the total time is negative 2 Vi over A. We then calculate the numerical value. We put in the numbers. We get 2.24 seconds, which is, of course, just twice the time to max height. Express the velocity of the ball right before it hits the ground in terms of Vi, delta t total, and A. This is just the kinematic equation, Vf equals Vi plus At, and then express Vf in terms of Vi. We use the delta t total from part H in this previous result, and we get that Vf is Vi plus A times negative 2 Vi over A. Notice we get Vf equals negative Vi, just as we would